Hi everyone, I'm Kanchana, working in SNS College of Engineering as an assistant professor in the Department of Chemistry. In this video now I'm going to say about types of chemical vapor deposition. Types of chemical vapor deposition: low pressure chemical vapor deposition, metal organic chemical vapor deposition, photon induced chemical vapor deposition, plasma enhanced chemical vapor deposition, atmospheric pressure chemical vapor deposition. Atmospheric pressure chemical vapor deposition. It works at atmospheric pressure. It is used to deposit a layer of material, typically several micrometers, thick onto a wafer or other type of substrate. It is also used as surface finishing process for items such as tools and turbine blades to improve lifetime and performance. Since a vacuum system is not required, atmospheric pressure chemical vapor deposition system have a relatively low operating cost. It has inherently poor utilization. It is extremely susceptible to oxidation due to greater mass density and residence times. Low pressure chemical vapor deposition. Uh, Coatings exhibit excellent uniformity, high purity, and good step coverage. It works at sub-atmospheric pressures. Reduced pressures tend to reduce unwanted gas phase reaction and improve film uniformity across the wafer. The lower pressure increases the precursor diffusion through the gas and mass transfer rate of the gaseous reactants becomes higher than the surface reaction rate. The pressure for LPCVD is usually around 10 to 1000 Pa, while standard atmospheric pressure is 101,325 Pa. Metal organic chemical vapor deposition. Metal organic compounds are used as molecular precursor to deposit a wide variety of thin film materials for new industrial applications. The great advantage of metal organic chemical vapor deposition precursor are their high volatility at moderate to low temperatures. Therefore, reaction temperature are lower 750 to 1100 Kelvin than conventional chemical vapor deposition. The main disadvantages are the precursors tend to be very expensive and are very volatile. Then reactive liquids are used. They require accurate pressure control and are difficult to purify. Laser chemical vapor deposition. Laser chemical vapor deposition uses a focused laser beam to heat the substrate. It also has the ability to locally heat a part of the substrate while passing the reactant gas, thereby including film deposition by locally driving the chemical vapor deposition reaction at the surface. It also has the ability to locally heat a part of the substrate while passing the reactant gas, thereby inducing film deposition by locally driving the chemical vapor deposition reaction at the surface. It is used to deposit microscale solid patterns or three-dimensional structures on the surface of substrate by a localized single-step process. Plasma enhanced chemical vapor deposition is used to deposit SiO2, Si3N4 and amorphous Si films. Plasma can be used to decompose a molecule that will not decompose at a reasonable elevated temperature. It can be used to decompose a thermally unstable molecule but at a much lower temperature. In plasma chemical vapor deposition, substrates that cannot tolerate high temperature such as polymers can be used where substrate temperature range from 100 to 1000 degrees Celsius. Advantages of chemical vapor deposition. Films are generally quite conformal. For example, the ability of film to uniformly coat a topographically complex substrate. Versatile, any element or compound can be deposited, high purity can be obtained, high density, nearly 100% of theoretical value, chemical vapor deposition film harder than similar materials produced using conventional ceramic fabrication process, material formation well below the melting point, economical in production since many parts can be coated at the same time. Disadvantage of chemical vapor deposition. Chemical and safety hazards caused by use of toxic, corrosive, flammable and or explosive precursor. Extra steps have to be taken in the handling of the precursors and in the treatment of the reactor exhaust. High deposition temperatures of often greater than 600 degrees Celsius are often unsuitable for structures already fabricated on substrates. Restriction on the kind of substrate that can be coated. It leads to stresses in films deposited on materials with different thermal expansion coefficients which can cause mechanical instabilities in the deposited films. Application of chemical vapor deposition coatings for a variety of applications such as wear resistance, corrosion resistance, high temperature protection. Semiconductors and related devices, integrated circuits, sensors and optoelectronic devices, fiber optics for telecommunication used in microelectronics industry to make film serving as dielectrics and conductors and oxidation barriers and, epitaxial layers. Thank you all.